Awesome, we are live. Okay, we're good to go. Hey everyone, how are you doing? We want to thank you for joining us for our webinar, first one of 2025. And we're excited that you're here. This one I'm excited for. I always have people ask me, what's needed on commercial site surveys and residential. So we put together a good PowerPoint that's really going to walk you through what we need to get your project started out right from the get-go. And we're excited for this year. And I'm going to turn the time over to the captain, Mr. Scott Whistling, to take us from here.
Thank you, Ben. I appreciate everybody support in these webinars for us and your support for Whistling Consulting as well. We certainly have tried really hard to be a resource to all of our customers as well as the industry as a whole. And I think we've done a good job at doing that. I know that there's always areas for improvement, but we've made it from day one. I've always felt that being all in the solar engineering end is super valuable, and to provide a resource from electrical, structural, and now from design as well, commercial and residential, has made us really an industry leader. And I'd like to thank all of you personally for participating in these webinars. I like formats where I ask questions of people, and I might, honestly just call on some of you, if you don't mind that. And maybe I won't, depending on how I see things going. But we did put together a slideshow and a presentation that talks about site surveys. And I've always, it seems the sticking point always is, and probably always will be, do we have to do site surveys, right? I know that there's a lot of companies that who are basically run by sales teams or sales managers, and a lot of them like, we could save money if we don't have to do site survey. And the honest answer is that it'll cost you money if you're not doing site surveys at the end of the day, because all you need is one project that a roof fails and someone gets hurt who's installing on it because they fall through the roof, or there's a lawsuit associated with it. So site surveys are always super valuable. I do recognize that there's firms that have tight budgets, and there's times when we can look at other avenues related to site survey, but on a regular basis, you're better off by having site surveys completed. There's several companies out there that do it, that provide that service, and that's all they do. Not even necessarily you need to have it in-house, which is pretty interesting as the market starts to change, that you're seeing that. So anyway, let me share my screen. Just by way of introduction, I think most people who work here, but you could see everybody who has their cameras on are really presenters in our webinar today. So you have Greg Elvestad, who's our in-house licensed electrical engineer, and then you have Heath Harpster, who's our in-house licensed structural engineer, and then you have Catherine, who is she's an electrical engineer, not licensed yet, but soon to be licensed, hopefully as of next week, right, Catherine? She's sitting for the exam. So she's been in this realm for over 14 years, maybe even longer than that, and she has an extensive background in commercial designs and engineering as well. So anyway, we're happy to be here and happy to have you guys participate with us. So let me share my screen and we can get started. So we talk about site surveys, and I guess through the eyes of an engineer, right? And that means that we may not see things the way you see them, but knowing how we see things from an engineering perspective may help you guys in what you're doing, and where you can provide those values on your end, right? So let's talk about basically residential first and what we look for. Pretty straightforward on a lot of the requirements. We look, basically, you see some of the photos that are on here. We look for the depth of the rafter. If it's a 2x6, it's going to be 5.5 inches. If it's a 2x8, it's going to be 7.25 inches or 7 1/8. And if it's 2x10, it may be 9 1/8 or 9 1/4, right? Those are dimensional lumbers for 2x material. You wind up seeing material that sometimes is true dimension. And before they started making dimension lumber, where they took off a little bit, right? 2x6 is 5.5 inches because they do it a rough saw and it comes out to be 2x6, and then they plane it down so that it's a finished thickness. You might have some before they started doing that are exactly 2 inches wide by 6 inches deep, and those are called rough sawn lumber. The support of those systems are a little bit more because they're obviously their cross-sectional area is greater, and their ability to bend in bending, which is what we look for, is different because they're bigger, right? So we look for the depth of the rafter, and we look for the spacing of the rafter. That's from left to right. We say rafters, but it could be trusses. It could be, there's a lot of different variation between roof systems, and then we also want to look at the spacing for those rafters and trusses as well. And that's usually what we're looking for, is some confirmation on those. And that usually is in the form of a photo with a tape measure that's on it. So that's typically what we like to see from an engineering standpoint. Not always practical. Sometimes you can't get into an attic. Sometimes they're finished ceilings. And we'll talk about that as well, right? So really, a couple photos, one that shows the spacing of the rafter, one that shows the depth of the rafter. Basically, this one shows the spacing, this one shows the depth, this one shows the spacing, right? Also, it's good to see like an overall view of the attic, something like this. So I could see, okay, I could see overall what the roof looks like. If I zoom in on some of those photos, I might be able to tell if there's a cracked rafter or if there's something I need to be aware of, right? So that's a good photo to have. So that's 3 that we really would love to see. And then we like to see an exterior photo, usually from the ground or on the roof, so we could see what the roof cover is. We could tell if it's a metal roof. We could tell if it's clay tile. We could tell if it's comp shingle, which most are comp shingle. And then obviously, if there's any other supports in the attic, then that's important for us to know, whether it's a knee wall or a purlin, and we want to see that as well. And do you guys know the difference between a knee wall and a purlin? If you don't, I can kind of talk through that a little bit, because that might be important for you guys to understand the difference. Yeah, who was it? Someone raised their hand, or they put the thumbs up. Brendan knows the difference. Okay. So a knee wall is usually completely vertical, and sometimes you'll see a knee wall in a finished area in an attic, right? If someone finishes off a room, they put a bedroom in there, there's an exterior, there's a wall, a knee wall that they'll build in, and they even finish it off with sheetrock to kind of make it so that it's not as low of a ceiling, that it kind of gives it an area where people aren't going to go past that, right? That's kind of a knee wall. You can have it in an unfinished attic, you can have it in a finished attic. It reduces the overall span of the rafter, so it gives you more support if you have a knee wall. Typically, we look for something below the knee wall that is load bearing, because if you're taking a load from the roof on a rafter down to a knee wall, and it's not bending the rafter any longer, it's putting that load into the knee wall, then that transfers the load from the roof down to the floor or the ceiling above, or the floor if you're in the attic, right? And that can be problematic if you don't design the floor joists to support that load from the roof. So that's why you look for a bearing wall below it. And a lot of times that's missed when you go out there. You might see a knee wall, but if you're looking to have us verify if that will work, sometimes we want to make sure that there's a bearing wall below it. So that's what a knee wall. It's usually vertical and it usually runs underneath the rafters. A purlin is usually at an angle, and there's a maximum angle that a purlin will work. And I think it's around 45 degrees, right? Correct me if I'm wrong. Look like Heath is shaking his head, so I got the nod of approval from Heath. So 45 degrees is usually the maximum. You'll see a lot of these in like areas like California, where they will actually put like maybe a 2x6 that's supported right behind the rafters. And then maybe every 48 inches, there's a 2x4 that runs down at a 45-degree angle with a notch in it that holds the 2x6. And usually they're at an angle because they're either bring them back to the main bearing wall in the middle of the house, or someplace below it there's another bearing wall. So even purlins are designed so that the load from the roof is being brought down to a load bearing wall someplace underneath the ceiling or floor joists that are in the attic. So that's the difference between a purlin and a knee wall. So now a lot of times you're saying, well, what do we do with a finished ceiling? So finished ceilings are viable ways you could still install on top of them. I tell a lot of my customers that I limit my exposure on projects. So I like to see as much information as I can get, but I know that when it's a finished ceiling, we sometimes have to take a little bit of a risk and maybe take a little bit of leap of faith in certain situations and make some assumptions. So I usually put assumed in my certifications, but I would love to see a photo of the finished ceiling to confirm that it is indeed finished and that there's no access into it. But the other thing to consider is that when you're looking at finished ceilings, a lot of times you'll find a skylight. And in this photo, you see a skylight, and you can take a measurement from the back of the skylight, from the glass or the framing of the glass down to the ceiling, the sheetrock on the ceiling, and you can get a measurement for that. And that's an indication of what the roof system is, right? Of what the rafter size might be. And it may not 100% be accurate, but it could be pretty close. Like, let's say that's 10 inches. I could probably make a pretty good assumption that's even if I'm conservative and put assumed in there, a 2x8. If it's 10 inches, a 2x8 is like 7 1/8. Odds are that there's going to be some other framing in there, maybe some sheetrock on top of it that you're taking in as a dimension. But I can say, okay, I'm pretty sure that's a 2x8. Measuring the width of the skylight from left to right, usually there's two rafters that are eliminated to put that in, and they might put a header on one side, a header on the other. So if it's 24 inches or if it's 32 inches from one side to side, I could tell kind of what the spacing is of those rafters from a skylight. The other thing that you can do when you're looking at finished ceilings is typically they'll have screws or nail heads that are somewhat visible, or there's shades in the sheetrock, the finished area, that you can measure between those to be able to get a spacing. So there's lots of things you can do with finished ceilings. The other thing you can do is we've told people you can drop a light, like a can light, in the ceiling, and you theoretically are able to get a measurement behind the box, the electrical box in the ceiling. A little tougher to do. Like, we've actually seen some people send us a little, you can use like a coat hanger to stick in there, and they've sent a coat hanger stuck inside the electrical box and giving us a dimension on that. And that's not really what we're looking for. You actually have to get next to that electrical box, slide it in next to the electrical box, right up against the sheetrock, and push it in as far as you can. But be careful, because you don't want to hit any electrical lines or wires, and you could hit the rafter if you're, depending on where you're pushing that metal up. But that's an indication too, where you could get a preliminary depth or some type of an idea on the depth of the rafter. And then the other thing too is you can actually measure to a finished you can measure to a finished window inside, right? So the dimension from the ceiling down to the top of the glass is, you have that as a measurement, and you can go outside and you can measure from the bottom of the soffit down to the glass. And the difference between that would technically be how thick the ceiling is, right? It works really well with flat roofs as well. You could do the same thing with a flat roof.
I want to interject real quick, Scott.
Yeah, sure.
Because that photo is not exactly correct. When you're doing it from the exterior, you want to measure to the top of the roof. So you don't want to measure to the bottom of the soffit. That's probably going to give you around the same dimension as the interior. You're going to want to measure up to the top of the roof. And then when you subtract
Yeah.
that off, that should give you the rafter size.
Yeah, that's a good point. And when you're doing a flat roof, that's what you would do. You'd go from the top of the roof, the flat portion, down to the glass, and then do the same thing on the inside from the bottom, from the ceiling down to the glass. And then the difference between that would technically be what the rafter size would be, or close to it. The other thing you can do, and we don't have a picture here, but a lot of times on the outside of the house in the soffit, soffits are usually aluminum, and they're usually pretty flexible that you can pop a piece of the soffit out, which would give you the ability to look inside the eave and tell kind of what that rafter is, because the tail of that rafter is going to come down into the eave, and you can get an indication from there the spacing and the depth. Those are some ways of having finished ceilings where you can get an idea on what the rafter sizes are and the spacing. You can also use a stud finder in the ceiling or tap with a hammer. You know, the tap test is really good. You know, I do that a lot when I'm trying to paint pictures. I'm not very good at it, but if I hang a picture on the wall or a ceiling and I'm looking for a rafter, I could do tap with a hammer. And I think most install crews are doing that on roofs where they can figure out where the rafter is when they get started. Pretty straightforward doing something like that. And I think, let's see. Yeah, so let's pause there and ask for questions related to some of these residential site surveys and what some of your questions may be on our end. And I don't know if Heath, was there anything you wanted to add to our discussion here that I may have missed, or either Greg or Catherine, either one of you guys have anything you want to add?
No, I don't really have anything to add on the residential end.
Okay.
Just one thing, the thought you had alluded to that briefly in talking about the probing of the opening in the ceiling. Like Scott mentioned, you could possibly make contact with a top corridor of rafter as you're probing up next to the box. So it's a good idea to take reference measurements from probably 3 or 4 different spots around the outlet to make sure that you are truly up against the roof decking.
Yeah, that's a good suggestion, Greg. The other thing that I didn't mention is there's a rod test that is pretty standard, and some of you may use that or not, but you can actually also do a rod test out on the roof itself, on the roof deck. What you could do is you can remove like a soffit shingle that goes over the soffit, remove a couple of them, which are really pretty easy to remove. That gives you the top course of the shingles, and you can theoretically drill a hole through that top course of the shingle where the cap shingle was covering it, and you can stick a rod down inside there to get a sense as to what the depth is there as well, too. Those are another option. And then what you do is you fill that hole with silicone or caulk, and then put the ridge vent or ridge cap back over it, so it's still watertight, right? And that way you can actually get in without having to do too much. You don't have to go in and cut any sheetrock or anything like that. So that's another way of getting some from depth. But anyway, so let's open this up for some questions before we move on to the rest of the slides. And actually, I would love to know what has worked for you guys in certain situations as well, too. So, you know, Ben, if you want to monitor, if you want to raise your hand, we can turn your mic on so we can hear your questions. And if nobody has any questions, that's fine. But this is a great opportunity to ask our group if you have concerns about site surveys. I know a lot of people, you know, it comes down to training. And one of the things that we offer to all of our customers is we're willing to hop on a call. And frankly, I'd even fly out to some of your locations if we need to and train your staff and go through some of that. We can either do a Zoom call or Teams chat. Okay, so Jeff, we have a couple questions. it looks like, Jeff, if we want to talk about your question, you said, what about residential ground mounts? So residential ground mounts, I would love to see a photo of where it's going to be mounted or installed. The residential ground mounts are not going on the roof, obviously, so we don't necessarily need attic photos, right? But I wouldn't mind to see a photo of the terrain on where it's going, because that tells me the slope, right? Because if we're on a steep slope, we have to worry about footings, and we have to worry about the low side of the footings being exposed if they're on a steep slope. And then it also gives me a sense to see what is the general condition of the ground in that area. Is it rocky? Is it got trees all over it? You know, and then I can make an assessment. But typically with ground mounts, if you don't have photos, it's not that big of a deal. Simply because we usually make some pretty conservative assumptions relative to the soil conditions. That's the biggest thing. When you're doing large commercial projects, you probably want to do a soil survey. It's worth it to spend, $5 or $6 grand to do a soil survey if the system sizes are a meg or bigger or even less, right? Because you can actually save quite a bit of money on the number of footings you're putting in based on the size, if you can assume a better bearing capacity on the soil conditions. But in residential applications, to spend the cost on the site on a soil survey probably isn't practical, because you might only have a couple footings. And so if you just do an oversized footing and be conservative on the ground conditions and the bearing capacities of that. So that's a good question, Jeff. Thank you. And let me know if I didn't answer all of that. And then Lemuel, how about the use of stud finders? Is it accurate? Stud finders are relatively accurate from what I've seen, as long as you have a good, strong, strong battery in it. Sometimes they get a little weird, and there's some that are better than others. I would try and get a higher end stud finder, but they are very accurate. And I've done that a lot, and you're usually within, you got a range, a couple inches, right? Usually you can see the start of that stud or the rafter to the end of the rafter. And sometimes you're pretty good on being able to figure that out, especially just for spacing. It does work. So I would definitely recommend using a stud finder to do that. Okay, so let's move on here. There's no other questions. And I'm going to turn the time over for pergolas and carports. I'm going to let Keith kind of take the lead on this discussions, and I can interject.
All right, thanks, Scott. Thanks everybody for joining. Hope everybody's staying warm. So pergolas and carports, it tends to be a popular place to try to install PV, whether it's they don't want to install on the house, or it just offers a better location, or you have overflow on how many panels you need. So the site survey requirements for that, it's going to be similar in a sense to an attic roof. So we'll still need measurements on the rafter sizes and the spacings. Sometimes they're called purlins on one of these kind of structures and not rafters. Normally those will span between two beams, or like in the photo shown below, it spans from the exterior wall of the home to a beam. So those big beams, we like the measurements on the sizes of that with the depth and the width of them. And it'd be good to have a photo just to show like if it's an LVL or if it's a solid sawn beam or something like that. We need measurements on the length of the rafter or the spacing between the supports. So the length of the rafter and the spacing between the supports should give you the same thing. That's basically the same measurement, depending on which one you want to call it. So in the photo down here, it'd be the measurement from the exterior wall to the beam. And that way we just know how long the beam's spanning, how much force is going to be on the rafters, and how much force that's going to put on the beam. Normally for these types of structures, you're going to have post supports for the beams. We like to have measurements of those as well for when we run our calculations, as well as the height. That's important, and the spacing between them. So if there's multiple posts supporting your beam, we'd like to have the spacing of those. And it's good to just give a sketch. If you have photos and you're out there surveying it, they're not usually too big of structures. So if you could do like a plan view sketch with what the sizes are and the dimensions, that's really helpful for us. We need photos of the rafter connections to the beam and to an exterior wall if it's available. Normally those are hurricane ties or something similar. Sometimes they toenail them or, toenail with screws, which isn't the same capacity as a hurricane tie. We usually like to see those ties. Need photos of the beam connection to the post. Normally that's another pre-manufactured product like a Simpson column cap they use, or like you see here, it looks like they just sandwich maybe a 2x6 on both sides of the post to make a seat for the beam. So they put the 2x6s up the side of the beam or up the side of the post, screw them in, make a nice seat for the beam to sit in, and then screw the 2x6s to the beam as well. And then an important part is to have a photo or some kind of identification on what the post connection is to the footing. Normally they're going to be embedded in the footings, but usually you don't want to embed wood into concrete, so it's going to be some kind of pre-manufactured connection. And then this is probably the hardest part, is to try to get an estimate on the size of the footing, whether it's just into a concrete slab, like it looks like this one's just mounted into the top of the slab, or if it's going into an actual footing. You don't usually want to try to dig up around the footing. Normally when the footings are designed, it's relying on what they call like an in situ condition, so undisturbed soil that gives higher capacity. So if you're digging to figure out the size of the footing and then backfilling in, you're not going to have the same capacity as you would as it's just like core drilled in or sonotubed into the existing soil. So our recommendations are to ask the homeowner. Sometimes they know if it's relatively new. Sometimes they're able to reach out to the contractor, confirm what they did. Sometimes they have plans of it, or if there's any photos from the original installation. It all depends on whether it was done when the homeowner lives there. A lot of times they'll take photos of the installation when they're going on. Scott, I don't know if you had anything to add on to that.
Yeah, I mean, it's not a good idea to excavate all the way down to the bottom of a footing, right? Because that's going to undermine it. But you can expose down to the top to see if it was a poured footing or not. Like a lot of times we'll look to find out if there was actually a footing poured or if it's sitting on a rat slab, which is really something that maybe 3 inches of concrete that maybe is not really enough to support the pergola and it wasn't built properly. But sometimes if you're able to excavate down to the top of the footing and you can see that it was poured concrete and take a picture of it, that's always good. And then he talked about sometimes they're embedded into the concrete. And then other times you have like manufactured connections. And usually Simpson is a big connector where it's like an L bracket that's metal that might attach to the concrete. Or sometimes it's cast in the concrete with a metal sticking up out of it that then it sits on top of this and it screws in from the sides. That helps from the corrosion of the water meeting the concrete when sometimes you have it above the concrete, but you have the Simpson connection that's cast in the concrete or anchored into the concrete to keep it so that there isn't water right at that joint. And most
times, a lot of them have like a 1/2 inch or 1 inch base that the post will sit on.
Yeah. Yep. And a lot of that, most times they're using either steel, which is waterproof steel. They paint it, prime it, right? Or you're using treated post that can last a little bit longer in a wet environment, right? So that's it on my end, Keith.
Good. We can move on. All right, so now to get into the commercial side of things. Normally on commercial framing, you're going to have steel is what's usually going to be, steel bar joists, and that would go between probably steel wide flange beams. Although sometimes out in California and like, apartment buildings and stuff like that, apartments, you're going to have wood trusses normally. Out in California for some industrial and commercial projects, it's going to be all wood framing for like on a flat roof. That's usually the only place you see that kind of framing, where you'll have like 2x4s spanning 8 feet, then a bigger LVL beam, and then that goes to a bigger LVL beam. But what we need on our end is, it's kind of the same thing, the size, which would be the depth and width, the thickness, and the spacing of the roof framing. And then we need the span of the roof framing or the space in between the supports. So I know it's hard to see on here. I try to dimension or add dimensions for everything I'm calling out over here. So this one has 2x6s at 24, spanning 8 feet in between some truss supports, some steel bar joists. So we need to know either, it goes back to the same discussion on the pergola, either the span of that framing or the space in between the bigger framing supports that gives us the same dimension. And then if those go to a bigger support, you need to know how far those span. So size of those supports, if possible, or a rough idea. I know it's kind of harder to get measurements on some of these bigger girders. Normally, you just get measurements on the smaller framing. That's more typical. If you can get like at least a depth or something on the bigger girders, that helps out. And then those girders are usually supported by posts. So we need to know the spacing between those columns or posts. And that gives us, the span of that framing so we can adequately check it. We like to know the makeup of the roof if possible. Sometimes you have insulation under the roof that's visible, but sometimes you don't, and it's all the foam insulation on top or the rigid foam insulation on top. I know it's hard to get a measurement of how thick that is, but it's good to have, especially if we have to add connections. We like to know how thick that is. And then, if it's metal, wood, figure out if it's metal, if it's a ribbed roof or a standing seam. A photo of the standing seam is good so we can pick out the correct mount that we need. And then just general photos of all these elements and an overall view of the roof framing, just to make sure nothing weird's going on. There's not like connections between the elements that we would say would be like atypical or something like that, or if there's not anything weird going on. All right, looks like we had a question. So for flat roof residential, if we can get up on the roof, what should we know about the makeup of the roof? Just like it. Okay. Usually for residential, you don't have foam insulation on top. So normally you're just going to see a membrane roof, and that's typically enough. We usually assume a 1/2 inch thickness for the sheathing if we have to do deck mounts. But yeah, that's usually it. It's hard to get a makeup. We don't want you to be evasive and drilling into the roof to figure that out. We've seen residential homes where they're made of all these structural insulated panels, and anytime the home has been made up of those, they usually have structural drawings calling out what it is and all the supports. So if you can get that, that'd be great. But other than that, most residential homes, it's just going to be sheathing, and so we can make that assumption. One thing I didn't note here is probably the most important thing is if you can get structural building plans, that's like the ace in the hole. We'll have all the framing information we need, and then you don't really even have to get us too much of a survey, maybe for electrical, and maybe just to confirm that there wasn't any renovations, it hasn't changed since those structural drawings. So that's the main thing. If you can get structural plans, we're golden. So.
Yeah, but Heath, it's important to note that you could get plans, but they may not be structural plans, right? So there's renderings, architectural plans, there's plumbing plans, there's a bunch of different sets of plans that are going to be included in a design of a major design of a building, but we're really looking for structural plans. They usually have S in front of them for the sheet numbers for structural. And if you look at a big set of plans, the cover sheet will have a table of contents or a list of plans, and it'll usually identify structural sheets will be separate, because a lot of times we've had people send plans over, but they don't know what they're sending us, and they're just sending us whatever they're given by the owner. But you really do need to make sure that the structural aspect of what we look at. It's good to see other plans, but they might be site plans, they might be drainage plans. They could be different plans that don't tell us what the roof systems are. So that's important to note as well, too. I mean, and to be honest with you, I mean, there are larger buildings. Most of these commercial buildings are going to be made with some type of a steel I-beam or purlin. They're going to have different, much beefier roof systems than residential homes. Residential homes, frankly, they're all just wood. Most of the time, 95% or 98% are wood rafters or trusses, and they're relatively stable, and we know the system. and pretty comfortable with them. When you get to the commercial, there's a big variety of different types of roof systems. You can have, as Heath talked about, you can have the TPO roof systems, you can have concrete roof systems, you can have metal roof systems, and you can have wood as the structural elements. You can have concrete. You could have pre-stressed concrete slabs. We've had a lot of people come to us with parking decks that are manufactured or pre-stressed concrete decks, and they want to put like a canopy on top of it. And we're like, well, we really need to see the designs, because you don't really design a pre-stressed concrete slab to have another building on top of it. You design it for whatever the parking deck loading is going to be. So there's lots of things that are important to know when you're looking at a commercial aspect. A lot more risk and liability associated with some of those. But we also do recognize that with steel I-beams, usually they're more uniform than wood, and we can make some better assumptions sometimes based on the sizes of these buildings, knowing that we're only putting 3 pounds a square foot on them, or maybe 5 or 6 when you're looking at ballast systems, right? So anyway, kind of what we would look at it from the perspective of an engineer when we're looking at commercial versus residential.
Okay.
Did you want me to go to another slide?
Yeah, if you can go to the next slide. We're going to get into some of these different types of commercial framing that you'll normally see. And this is going to be more like larger commercial and industrial. So steel bar joists. You would think that you could just get a depth and a width and that would tell you everything you need, but that's not really the case with the open web steel bar joists. So SJI, which is the Steel Bar Joist Institute, kind of governs the design of these. And I think they give like regulations based on the typical bar sizes are, say, like a 22K7. That means it's 22-inch depth, and then that has a certain capacity to that. They don't regulate like what angle sizes and everything you need on that. I think they only give a capacity, and then the manufacturer has to meet that capacity to call it that bar joist. So the sizes of a steel bar joist, as far as like the angles and the webbing and everything, are different by per manufacturer to manufacturer. So what we can do when you have existing steel bar joists out there is the SJI actually has a form that you can submit, and you basically give them all the information you can on it, and they'll actually tell you, hey, this is from 1980 and it's probably this size. And that they have references and you can look those up, and they have the load tables and everything. So what we normally need to be able to submit that form is the angle sizes. So the top and bottom usually have 2 angles each, and they would be different between the top and bottom. So we need the size, both leg sizes, and the thickness, top and bottom of those angles. We would need the size of the bar in the middle. Sometimes that's a round bar. Sometimes it's another angle that they use, and they crimp it at the ends to fit up in between the top and bottom chords. So we need to know what that size is, the depth of it overall, the panel length or panel dimension, which is you have those steel bars in the middle. That's if you go on the bottom, where it comes down to the bottom chord, it'd be the spacing in between where it comes down. And then the overall length, spacing, and the age of the building. So they use the age of the building to figure out, what was this from 1980? Was it from 1960? What catalog do we need to look in? And then you put all that information in, submit it, and they usually get back to you within a day and tell you what the size is. So then we can double check and verify everything with that. Steel wide flange beams are pretty easy for us to look up. There's a steel, what is it? AISC. It's a steel construction book, I guess. And it's got tables of all the I-beam sizes. And what we normally need to be able to figure out the size in reference to that book is just the depth, the width, and the thickness of the flanges. So you have those flanges on the top and bottom. Those are going to be the same thickness that's uniform. The web is a different thickness, but normally you don't have access to get a spacing on the web unless it's at the end of a beam. But then, you have a connection there, so it's hard to get that dimension. Normally, with just the depth, the width, and the flange thickness, we can make a determination on what that size is. And then you also have pre-engineered metal buildings, or PEMB for short, which are the buildings that you see the C or Z purlins. If you look in the bottom left photo, that's a Z purlin. And if you look in the left of the top photo, that's a C purlin. For those, we normally need the measurements. So the depth, the total width, and the thickness. You're going to want to have a caliper of some kind, or I think they call it a micrometer sometimes, and that would give you the thickness. Normally those are going to be 16 gauge, 14 gauge, or 12 gauge, so they're pretty thin. And then it's also good to see a photo of the supporting beam. Normally these are like 4 foot, 5 foot on center, spanning around 20 feet or more. And then there's a huge steel, basically an I-beam, and normally they taper in size. Normally they're not uniform depth. We don't necessarily need the dimensions on that normally, but if you can get a photo of it, just kind of showing it, and the spacing of those, and then also, there you go. So that's what you'd normally use to figure out the thickness. And then, I was going to say, you made me lose my train of thought, Scott. So when these purlins go over top of the beam,
Sorry.
yeah, they normally lap each other. So it's called a lap length. It's basically where the members splice each other and connect to each other. So they don't just go over top of the beam and stop, and then another one starts like right next to it. Normally they'll go past each other and connect like 1 feet or 2 feet. And that's really important in knowing the strength of these purlins. These types of buildings are basically designed to 100% capacity from the get-go. So every little bit of information we can get helps. And that is, I mean, if going from a 1 foot lap to like a 2 foot lap can change the capacity of those by like 30%. So that's good to have. And we do have our in-house SE specializes in metal buildings like this. So, I mean, as far as engineering firms, we're probably one of the best ones to go to as far as installing on these types of buildings, as far as our knowledge. I don't know if you had anything to add, Scott, or if you just want to open up to questions on the commercial end.
I don't really have anything to add, oddly enough, right? But yeah, I don't know. Did we answer Jeff's question on flat roofs? I don't remember if we
I
added that
tried
in
the
or
best
not.
I could. It's for residential. Normally, we assume half-inch sheathing. Sometimes there's insulation between the rafters below. So if it's finished underneath the rafters and it's not exposed framing for residential, it should have insulation below the ceiling. So normally you're not going to have insulation on top of the roof for those. So usually it's just going to be half-inch sheathing.
Perfect. Thank you.
Yeah, did we have any
Are
other
there-
questions
before-
on commercial for the?
Yeah, before we move into electrical end of the seminar or webinar, is there anybody who has any other questions related to either residential or commercial structural engineering questions? Okay, I'm going to turn the time over to Greg Elvestad. He's going to talk a little bit about the electrical portion of site survey and what's required there.
Thanks, Scott. Greetings, Earthlings. We really appreciate your time here. Time is valuable and you have things to do. We want to take advantage of a short period of time to shed a little bit more light on why surveys. Like Scott said, there are those who would rather not do them, but that's a risk you don't want to take. Trust us. So for starters, when we're talking about looking at a structure, be it residential or commercial, the requirements are pretty much the same. We're going to want to see the electrical equipment because what we're doing with this stuff is we're making electricity and we got to plug it in somewhere. It does us no good unless we can plug it into something, be it grid or off-grid situation, the condition is still the same. You can take all the photons in the world and convert them to something, but unless you can plug it in, it doesn't do you any good. So looking at the list here, all sub panels, electrical panels of any size anywhere on the property is very, very helpful. Residential, usually there's maybe 1, 2, or at most 3, depending on the size of the home. Commercial can get quite busy. You could have a dozen or more panels all over the property, depending on the size of the service for the operation. So we want to get those. To the extent that you have qualified individuals that can assist with this, And I want to put that out there. Qualified individuals are those who've had training, electricians, etc. Plant electricians take advantage of that situation. If you've got a plant maintenance person, have them help you. But get the panels open, pull the dead fronts off, get good clean photographs. High resolution is best because sometimes we need to zoom in and see what's going on behind the panel. Breaker schedules, they are a code requirement. Now, some buildings have been up since dirt was new. They won't necessarily have good breaker schedules. You want to make sure to attempt to locate those, but the sizes of the breakers is very, very helpful. One of the things that is really helpful, and we don't get this a lot, but would implore our clients, and if you're not a client of Whistling Consulting, we'd sure love to have you on board, but a site layout drawing, a site plan with the locations of these panels is so very helpful, especially when we have to do fault analyses, arc flash analyses. The distances to these locations is crucial in having a sound analysis of the property. Next is equipment locations on the building. For example, if you get photos, Scott, I'm going to steal the screen for just a minute to do some photo sharing with our client, our audience. I had a client send these photos over, and it was a perfect example of a fantastic commercial survey. You got a step back shot of the service entrance. You can see the riser pipes coming down from an attachment on near the top of the building, and a current transformer cabinet, and the panel board to the right or to the left. Step back view, a little bit more perspective on this. Inside, where possible, again, qualified individuals only, please. Would not recommend you pull the cover off and stick a camera back there if you're not sure what you're doing. I want you to come back home with all your digits intact, please. This one was great because we got a shot of the connections inside, and I'm gonna say, hey Dan, wouldn't it be great to have seen this on every one of these that we worked on together? An extra port on the lugs available for a supply side interconnection. Fantastic opportunity to connect on this one here with very little intrusion. Still have to shut it down with the help of the power company, but that gives us a good idea where we can connect. And finally, a shot here from the other side. Again, seeing what is available for installation. A fuse disconnect could live right here next to the meter set just around the corner and still be within our 10-foot limitation for conductor distance on the supply tap. But these are the kind of photos that we really love to see, and this gives us a good perspective on where stuff can be installed. Because one of the biggest failing points about getting equipment installed on a structure is working space. That defined working space is roughly the size of your kitchen fridge. 6.5 foot tall, 30 inches wide, 3 foot deep. If you can't park a fridge against the wall and not have it tip over where you plan to put some equipment, do not attempt to put electrical equipment on that wall. It's not code compliant. The platform where you need to work has to be flat. Now, it can be a platform, but if you're working on terra firma like you would be here, it better be flat. And the reason for that is safety. You want your feet firmly planted on whatever you're standing on, so you're not worried about slipping and falling, and you don't have your head in the game inside the panel you're trying to play with. So, okay, Scott, I'll turn it back over to you to take the screen back again.
Okay, and I may have advanced on a slide or two here, so let me just share my screen again. And I'm at the first residential electrical commercial slide. I'm not sure if I was there before, but anyway.
Right. If we can back up one slide to the transformer picture real quickly. Just want to touch on
one more
that.
forward.
Yeah, right there. Up the other direction, Scott. Sorry. Right there. Yeah, the transformer picture for residential is not such a big deal, but the one with the pole and the transformers. If you can get photos of the transformer, sometimes they're going to be ground mounted, sometimes they're going to be pole mounted, but they're usually, if that's going to, there should be one slide in between these, Scott. The first one.
More, just go forward.
Right there. There we go. If you'll notice on the transformer on the right-hand side of the photograph, If you zoom your screen, you can see that there's a 50 stenciled on the can. And that's done for the power company personnel's purposes, but also it's helpful for people like Catherine and me to be able to decide how big of the transformer service is. That 50 means 50 kVA, 50,000 watt transformer. So this transformer bank on the pole is a 150 kVA transformer set with the a three-phase service going to a structure. This is helpful in making sure, number one, can we put as much PV on this property as you're trying to do? Sometimes the service may be undersized. Dirty little secret, because I used to be a power company engineer, you're not going to find a 3,000 amp service with a 3,000 amp rated transformer. It's just not going to happen, because we didn't invest that kind of money to have it sit there only to be utilized less than 25% of the time at its full capacity. So most of the time, the service transformer is likely to be half the service entrance rating. Could even be smaller. So be aware of that as you're looking at these. Utility bills to calculate load is very important. A lot of times a utility or an AHJ will want to know, okay, how much load is on this property, and is the service, or is the PV size that you're proposing way oversized for their consumption, or is it in line with their consumption? And so we have to do load calculations for that. There's a number of different ways to do that. Residential bills are almost never going to have kilowatt demand. They will have kilowatt hours energy consumption, but that's it. And even some commercial billing profiles, the same thing, just energy, not demand. But to the extent that you can get demand, which says kilowatts demand on a bill, please do that. That's very helpful. Now, sometimes you may have to actually set a recording device for a period of time in order to get that information. But if you have questions on that, just reach out to us and we can talk through that. Let's go ahead and skip to the next slide, please, Scott. That ended the slideshow. So the residential photos, if you've done work in residential, you know what the service panels look like. Sometimes they're an all-in-one panel outside. Previous to that, Scott. All-in-one panel outside, like in California, or some of them in Texas, Florida, or here in Utah. You're going to have pictures of the meter with a capability of distributing load outside, and it also feeds an interior panel. Get photos of those panels. Again, just like I showed you with the slideshow earlier, step back and then as you can locate all of those, get clear photographs of those, including breaker schedules. The one thing I'd like to wrap up with here is, as a surveyor, you are the eyes of the engineer. So that's why we have this conversation today, is to touch on some points of the things that Heath and Scott and Catherine and I would be looking for to be able to properly engineer your system. Overhead versus underground service. Some jurisdictions, they want to know that. Damage. If something looks like it's damaged, take a picture of it. If there are things in the way of that service, step back a couple of feet more and get a picture of what that is. Sometimes obstructions like a washing machine or trash cans, or even a shelving device in a room, could be perceived as a permanent obstruction, but sometimes it's not. You can just move it out of the way and still do the work. But the bottom line is that space that I talked about, the refrigerator space, you can't have anything there. So any permanent cabinets, sometimes you've seen a panel mounted inside a cabinet and then there's a countertop in front of that. Yeah, that's a major obstruction. So all of those sorts of things, if it looks weird, take a picture of it. And hopefully this has given you a little bit more ammunition to think a little bit differently and more like an engineer. Now, heaven forbid that you would want to think like an engineer, because we are a strange breed, but it gives you an idea why we ask those kind of questions. Okay,
Thanks,
Scott,
Greg. I appreciate it.
turn it back over
It
to
looks
you.
like Austin has a question. So if we can see if I can unmute Austin. All right. So Austin, I think you're good to go if you have a question. Oh, it's like someone muted you again.
All right, it unmuted me and then it muted me and I had to unmute myself. Thanks for unmuting me. Just a question, a quick question. Do you guys have any tips or tricks when trying to convey or give an idea of wire size, like in a main service panel? It's been kind of a pain point for me in the past. Just like conveying whether it's like, 4/0 or if it's 2/0 or you know what I mean? Because sometimes in the photos it can look a little bit different than what it is, or the insulation often it's a cable, so it's on the sheath, and so you don't see it on the insulation, or it's worn off. Just seeing if you guys had any tips or tricks for documenting wire size.
That's a great question, Austin. Let me try to give you a practical example. Now, this is a little bit extreme here on this photo, but if you'll notice the wire coming in and the exposed threads on the set screw. This one here is likely to be 500,000 circular mils, just because it's pretty full and there's a good portion of the set screw exposed. And you notice the one on the right is clearly fully seated and there's nothing in it. A little bit of extreme, but when you look at the service panel, take a look at the set screws. And now, it's not 100% accurate, but it is pretty good. If you see one where it's quite a bit exposed threads, 3 or 4 threads exposed on a panel that's 200 amp rated, there's a pretty good bet that's 4/0 aluminum. Now, one of the things to remember about electricians in general, my best friend's a master electrician, and he tells me I'm the only engineer he can stand. So I'm going to take about 5 seconds here to address that. Is that they would never have put in a full capacity 200 amp rated wire. They're going to follow the 83% D-rated rule, so 4/0 aluminum or 2/0 copper. Or in the case of 100 amp service, number 2 aluminum, or even a 4 copper, or 125 accordingly. But always look that the wire size is going to be smaller than the actual rated service, and that's okay because that's what the code said. I can't explain it because it's been that way for 100 years, but that's a good gauge. Take a look at the screws, and go from there. And if you do have questions, just ping us and we can talk through that. I do have calibrated eyes. Okay, I really don't, but that's beside the point. Anyway, does that help?
Yeah, that's helpful. Thank you.
Thank you for your question, Austin. Appreciate it. Anybody else? Well, that concludes our presentation. So if there's any other questions on anything that we talked about, now is the time to ask. We are excited. I think this is a valuable call. I think a lot of times there's a, difference between what we look for from an engineering standpoint and what you guys or site surveyors are looking for in the field. And sometimes we need to, meld those together. And like I said, we're willing to hop on calls and talk through some training with site surveyors about questions on what they're looking for. We do that quite a bit. And we're willing to do that for any one of you guys on this call or anybody who has any questions related to that as well. So anyway, we're hoping that you guys are doing well in the industry. I know that it typically gets slower through the winter. We've experienced that. We have seen less of a decrease in volume over this year as opposed to last year. So we're hopeful then, as I hope all of you are hopeful, that we are going to see a little bit of a rebound for 2025. And, hopefully we all can get back in the swing of things as it comes to doing solar and having the volume there. So are there any other questions related to anything that we talked about today, or either any other questions that someone may have that maybe someone on the call could answer? This is the time to do it. All right. Well, guys, thanks so much for taking the time out of your day. We're right at the hour mark. So I'm going to thank everybody again for attending. Look for a next webinar for next month. You're welcome to send us some suggestions, even if you want to put them in the chat on things that you might want us to talk about. But we're more than happy to tailor some of our webinars to questions that you guys may have specifically. So, but again, thank you for all that you guys do in the industry. It's wonderful to be involved with professionals and be in this platform with you, and hoping we can help you guys through the solar coaster that we all talk about. So I don't know, Ben, if you had any parting thoughts, or if we want to just end our discussion.
Nope, you summed it up well. Just a lot of gratitude for you guys. Thank you, and have a beautiful day.
Thank you, guys. Take care.